In this video, we are going to see about digital signature and how hashing and asymmetric cryptography is used in digital signature and the process of creating and verifying a digital signature using a crypto software. First of all, we're going to see what is a digital signature, how it works. What is a digital signature? A digital signature is a mathematical algorithm used to validate the authenticity and integrity of a message. It creates a virtual fingerprint that is unique to a person and are used to identify users and protect the information in document. Uh, is a cryptographic value that is calculated from the data and a secret key known only by the signer. Why would you use a digital signature? There are several reasons to implement digital signatures to communications. It provides authentication, integrity, and non-repudiation. It ensures the integrity by creating a digital signature of a message using a sender's private key, and it ensures the confidentiality also. How it works. Digital signature scheme is based on public key cryptography. Public key means the scheme has a public private keeper. Generally the keeper used for encryption and decryption and signing are different. And the private key is used for signing is called the signing key. The public key is referred as the verification key. And here the signer or the sender first feeds the data to a hash function and generate the hash of a data. Hash function, what is hash function? Hash function is a fixed length string of numbers and letters generated from a mathematical algorithm and files such as email or document, a picture or some other type of data. This generated string is unique to the file being hashed and is a one-way function. Some examples are a SHA-1, SHA-2, MD5, etc. Then the hash value and the signing key, that is the private key, are then fed to the signature algorithm, which produces a digital signature on given hash. Then the sign is appended to the data, and then both the data and the signature are sent to the verifier or a receiver. Then the verifier feeds the digital signature and the verification key, that is the public key of the sender, into the verification algorithm. The verification algorithm given some value as output. The receiver also runs some same hash function on received data to generate the hash value. For verification, this hash value and the output of verification algorithm are compared. Based on comparison, the receiver decides whether the digital signature is valid or not. Now we are going to see how we can create a digital signature, how we verify that using the Cryptool software. A Cryptool is an open source software designed to demonstrate the application and analysis of encryption algorithm. first I'm going to create a document, the plain text message. Save the file. There are two ways to be followed in crypto for creating and verifying a digital signature. The one way is using PKI. Using PKI, wherein we can generate or import keys, then signing a document, then verifying the signature. And another way is using the signature demonstration, we can create the digital signature. Now I am using the PKI. Generate or import keys. Keys can be generated by any of these algorithms: RSA, DSA, ellipticus. Uh, now I'm choosing RSA algorithm. So for using asymmetric cryptography, a pair of keys are needed, a public and private key. PIN number. And the crypto will enable us to create a new keeper. Now this keeper is the keeper is generated using a large random prime numbers. Then so we are successfully creating the keeper. This is my key. These keepers are generated using a large random prime numbers that are selected, and the algorithm, that is we are selecting RSA, is applied to on those two randomly selected prime numbers. So for authentication of public key, digital certificate is needed at the receiver side to make sure that the public key actually belongs to the sender. So the receiver can make use of the public key infrastructure to take the digital certificate of sender. So this is the digital certificate of this document. After that, we are going to sign a document. Sign this document. Signing means we are using a hash function. We are going to use a hash function. So the hash functions are there. I'm using MD5 pin number. So I'm going to click on sign. So This is my key. This is the signature. This is my original message. This is the signature of this document. So we are successfully create the signature for this document. So after creating, once the document is signed, then we can we are going to verify the document. We can verify the signature with the help of hashing at the receiver side. We can compare the message digest and apply the hash function to the message. If both are equal means the signature is valid. So now we are going to verify the signature. Choose the key. Click on verify signature. It shows the signature is right. The correct signature is a valid signature. So if any change, any modification is made in the message means it shows the invalid it is an invalid signature, like that. If now I'm going to delete some portion of the message. Now we are going to verify the signature. Click on the keys, verify signature, which it tells that invalid signature. Like that we can verify the signature. So we are successfully creating a digital signature, signing it and verify it. Now we are going to see about symmetric encryption. Symmetric encryption, we know that symmetric encryption is a type of encryption where only one key is used to both encrypt and decrypt information. In asymmetric, we use a pair of keys. So, but in symmetric, only one key is used. By using symmetric encryption algorithm, data is converted to a form that cannot be understood by anyone who does not possess the secret key to decrypt it. Once the intended recipient who possesses the key has a message, the algorithm reverses its action so that the message is returned to its original and understandable form. The secret key that the sender and receiver both use could be a specific password. In symmetric encryption, some example of symmetric encryption algorithm are AES, DES, RC4, Blowfish, etc. So now I am creating a plain text. I'm going to create a password. I'm going to create a key using this password. Let's copy this. Now we are going to encrypt this document. I'm using a symmetric encryption and AES algorithm. Paste it. Click on encrypt. So now I encrypt this document. Save this file. Now we are going to decrypt the file, the same file. This is my original text. So we successfully encrypt and decrypt this document using symmetric key encryption. Thank you.